Good evening, all of you. So in the previous week, we discussed about what? The control and coordination system in humans, especially in animals. Okay, yeah. So in that, what are all we discussed? You remember? Yeah, we started with the different kind of movements. Yes, what kind of movements? Visible movements, invisible movements, voluntary movements, involuntary movements, internal, external, whatever. So there are different kind of movements. Okay, and it may be any kind of movement, but still all movements are under control. So there is an important process inside that which controls all of the processes in living organisms. So this is what we discussed. And what that process, that system is called what? Control and coordination system. That system was called what? Control and coordination system. And then we discussed about the different components of control and coordination system. So what are they? Central nervous system. How did we classify? Central nervous system, peripheral nervous system. So central nervous system consists of what? Brain and spinal cord. Very good. The peripheral nervous system consists of nerves, different kind of nerves basically, like cranial nerves, and then spinal nerves. So whether they are called peripheral nerves, cranial nerves. What is the function of the cranial nerves? Hmm? All the organs above your head are connected to what? The brain through cranial nerves. The rest of the body, all the tissues and organs are connected to the brain through spinal nerves. So, rest of the body, spinal cord, and then central nervous system. So those nerves are called what? The spinal nerves. Okay. And then we also discussed about the autonomous nervous system. Did we discuss? Only central nervous system we discussed, right? Fine. And then we discussed about we started our discussion with the anatomy and functions of physiology of what? Brain. Central nervous system. The brain. Brain is covered by cranium. Cranium. Just that. The triple membrane layer.
Yeah.
Hmm?
Yeah.
Three meninges. So what? Meninges. What are the three layers that meninges?
Neuron.
Dura matter, arachnoid matter, pia matter, whatever. And then the right and left hemispheres, forebrain, midbrain, hindbrain, cerebrum. Okay, the lobes, occipital lobe, and diencephalon are the three components of what? All the components of what? Forebrain. Midbrain. What is there in the midbrain? In the midbrain, the aqueduct. Okay, the corpora, which connects what? Forebrain with hindbrain, which forms the stem, brain stem. And then the hindbrain, pons feroli, cerebellum, medulla oblongata. What are the functions of pons feroli? What it does? Respiratory, the pons feroli. Then medulla, of course, that heart rate, breath rate, all kind of that involuntary actions are controlled by medulla. Is it clear? So like that, the major parts of the brain and its functions we discussed. And then neuron. What is the basic unit of nervous system? Neurons. So the structure and component of neurons is right. Hydrogen means the dendrite, cell body, axon, nerve endings. Right? What else? Strand cells, myelin sheath, vessels, granules, node of Ranvi, nodes of Ranvi. All the glial cells, neuroglia, myelin sheath, all these things we discussed. And then how a neuron transmits impulse to the nerve ending, like neurotransmitter, acetylcholine, from one neuron to other neuron, from one neuron to other non-neuron cells. So this is what we discussed in the previous class, right? So hope you have an idea about the things which we discussed in the previous class. Also, we discussed about what? Did we discuss about reflex action? Reflex action? No. Yes or no? Fine. So reflex action we have to discuss. Okay. So now we'll start with the reflex action. Did we discuss about the autonomous nervous system? No. Only central nervous system we discussed. Right. Of course, peripheral nervous system, the nerves, different kind of nerves, cranial and spinal nerves. So now we just started discussing with the autonomous nervous system. Okay, today we will discuss about the autonomous nervous system. In that, we have two different components like sympathetic nervous system and parasympathetic nervous system. Okay, and then reflex action. Okay, and then reflex action. Then some electrophysiological techniques of the functions of central nervous system is measured, the electrophysiological techniques. So all these things we will discuss in the first session, and if possible, we can move to plants, control and coordination system in plants, right? So, we discussed about central nervous system, you know the components, peripheral nervous system, and now autonomous nervous system. Okay, autonomous nervous system. Autonomous means what? Almost independent. Autonomous means what? Independent, on their own, on its own. In simple layman meaning for autonomous. On its own, auto, self, அப்படின்னு சொல்றோம் இல்லையா? So on its own, by itself, by themselves. This was the simple layman meaning for autonomous. Okay, so we have autonomous nervous system. Okay, so can you suggest? Can you just think what are the organs comes under this autonomous nervous system? Means they can function in the body no matter your thoughts, organs and organ system, the processes, autonomous nervous system. Any idea? Right. Okay. So no, the organs which can, or the tissues which can have that self-control, you can say, self-organization, self-contraction potentials. So they are basically we call involuntary activities. Okay, autonomous nervous system controls involuntary activities. Okay, autonomous nervous system controls involuntary activities of our body. You know the basic difference between voluntary actions and involuntary actions. So what about voluntary actions? Yeah, means the thinking is involved. You can have a control on this. Means if you command your hand to open, it opens. If you command your hand to close, it closes. If you want to write something, you just command them. Write the name. It writes. So all these things are what? Voluntary actions. Voluntary. We know already the forebrain is the main thinking part which controls such kind of voluntary actions. Now the involuntary actions, which you don't have to command, depends upon the situation, they does their function. For example, if you are relaxed state, if you are in a relaxed state, you are at rest, sleeping. What's a normal heartbeat? 72 beats per minute. Okay? When you are at rest, what is your respiration rate? 12 to 16 cycles per minute. Right? Fine. Now, you're going to run for a while. Do you command your heart or lungs to? No, 72 beats are not enough for me. Okay, 150. Can you control? No. 16 cycles are not enough. 30. Do you control? No. So it depends upon the need. They regulate. These organs regulate. They can increase its beat rate, respiration rate on its own. If they want, they increase. If it is not necessary, they just decrease. That process is actually called what? regulation, self-control. So the autonomous nervous system will have its own self-control. Self, you can say, proper technical term is self-regulation. Can you understand? Such actions are basically called what? Involuntary actions. In our body, they are very, very essential. Since you are multicellular organism, so every cells in the body should get its oxygen, food, everything. So the involuntary actions plays a crucial role in controlling the rhythm of body. Okay? Can you understand? Now, if I list you the organs which comes under this involuntary actions, obviously you can connect their functions also, and when they does such kind of functions, also you can connect. Okay, so note down the organs. Okay, can you see the different components, examples of components of the body which can regulate their functions. Okay, self-regulation of their blood vessels. Okay, what is the function of the blood vessels? What it does? Transportation of the blood. Your blood is transported at a same rate in all of the time in your body? No. Right. Sometimes it is the blood pressure is high. Sometimes it is low. But if the pressure is high or low, same vessels only transport your blood. Is there any other separate route for transportation of high pressure blood and low pressure blood? Then how it can regulate? How the blood vessel knows that now I have to hold on the pressure rich blood, or like I have to transport pressure less blood. How they adjust themselves? High blood pressure, low blood pressure. How do the blood vessels adjust themselves? How do they adjust themselves? Two processes. Okay. Constriction, dilation. Okay. Blood vessels. How do they adjust? Constriction. And then dilation. What is called the constriction and dilation of blood vessel? See, dilation means the volume of the inner volume, or you can say the space inside the hollow tube is decreased, means increased. Okay, if the tube is narrow, what occurs? If the blood is also passing in high rate, it may affect. So, for the slow down of blood pressure, if the blood is coming with high pressure, how it should adjust? To have a rhythm control, it should dilate itself. Dilation. Can you understand? So, this is the blood vessel, just assume. This is the blood vessel. The blood is coming with high pressure. What it has to do? If it is not safe, what it has to do? How it controls? It just dilates. What is called dilation? Look at it. Like this. Can you see? Dilation, just to have the control. Okay, what is dilation? You can see this is the normal volume like space, the blood can flow. If the pressure is too high, it should be controlled. To make the control, the blood vessel dilates. Now, the flow can be adjusted. Can you understand? That is called what? Dilation. Constriction. Again, back. The blood pressure is required. For example, you're sleeping. Okay? When you're sleeping, maybe you are in relaxed state, dilated state. If always your blood vessel remains in dilated state, no filtration can happen in your kidney. We saw in life processes, right? Kidney, their blood vessels are there. It should dilate, constrict. It should dilate and constrict. Right? So for that, constriction has to be there. What has to be there? Constriction has to be there. So then the size reduces. Can you see? The size reduces. Is it clear? Can you give me an example of an hormone? Some hormone which how blood vessel does this constriction and dilation process? Can you give me example of some hormones? Do you remember? Vasopressin. Vasopressin. We will be studying about this hormone. Vasopressin is a hormone which is produced in your brain. Actually, we are going to discuss about different glands. Okay, so there, this vasopressin is produced. It is actually called what? Antidiuretic hormone. Another name is called what? Antidiuretic hormone. Keep this in mind. Hormone. Of course, we will be discussing about different kind of hormones. Okay, antidiuretic hormone. If your blood pressure increases, they just dilate your blood vessel. What do? They just dilate. Then the pressure is decreased. And there are another mechanism is there. That is called what? Renin angiotensin. What is the hormone? Renin angiotensin mechanism. These hormones are vasoconstrictors. What do? Vasoconstriction. Vasopressin is the dilator. Angiotensin renin mechanism is actually a constriction mechanism. So the hormones itself can does what? Especially in kidney, vasoconstriction, vasodilation. You don't, I said cure glands, blood vessel glands. These glands are actually called endocrine glands. We will be discussing that. The glands, if it knows, yes, the blood flow is high, they sense vasodilator, vasopressin. No, the blood pressure is low, need more filtration. It sense and means renin angiotensin mechanism hormone basically. Can you understand? So this is one just example how the rate of blood flow, especially in kidney care, the blood vessels basically, how the filtration is regulated. Okay, so this system like that for every organ state, different hormones. We have a special mechanism for different glands. That system is actually called what? That is called what? Autonomous nervous system. Can you understand that is called what? Autonomous nervous system. Okay, fine. Smooth muscles. What about smooth muscles like that? This example you know. Smooth muscles, your lungs or whatever. They contract on their own. Okay, and then your alimentary canal. What's your alimentary canal? You start with mouth and end with anus. The transportation of food, absorption of food, another substances, water or whatever, minerals, nutrients, whatever, and then excretion of waste, under the control of alimentary canal only. Upper part of the alimentary canal, absorption and digestion. Lower part of the alimentary canal, excretion. Again, it is under the control of what? Autonomous nervous system. Uterus, uterus. Yeah, the baby is developed. We are mammals. Baby is developed inside the womb. Uterus. Have you heard that? Fetus ejection reflex, a process called fetus ejection reflex. What is it? If the baby is fully developed inside the body, it sends a hormone. It produces a hormone called what? Oxytocin. Okay, what is it? Oxytocin. It is the contractile hormone. Oxytocin is a contractile hormone. So the fetus sends this hormone. The cells in the uterus activated, the signal reaching the brain. And then in the brain we have pituitary. So there, more oxytocin, we have neurocentric cells in the hypothalamus. More oxytocin is released, it comes, and there it makes the uterus tissue to contract vigorously. That is called what? Labor pain. We call it as what? Labor pain, no? Delivery pain, birth pain. So that's because of what? Contraction of the uterus. So that results in what? Delivery of the baby. Can you understand? So like that, in our body, most of the actions which you cannot control, we cannot control, are properly regulated by autonomous nervous system. Okay, examples of the organs are all these things. Literally, starting from the little blood vessels, simple glands to uterus, and all those smooth muscles and major organs. Can you understand? So that's the importance of what? Autonomous nervous system. Okay, even without our thinking or control, they regulate their own functions, depends upon the situation of the body, the rhythm of the body. Okay, fine. Now, this autonomous nervous system is again divided into what? Two important cells. Just for the regulation, two important cells. What are they? Sympathetic and parasympathetic. Okay? Again, autonomous nervous system is divided into sympathetic and parasympathetic nervous system. Okay, we'll make a table column for sympathetic and parasympathetic. organ, sympathetic nervous system, parasympathetic nervous system. What happens in all of these things? Okay. First, heart. Okay. The sympathetic nervous system increases heartbeat. Parasympathetic system decreases heartbeat. Okay. Sympathetic nervous system increases heartbeat and parasympathetic nervous system decreases heartbeat. Okay. In blood vessel. Okay. Sympathetic nervous system constricts vessels. Okay. Constricts vessels. Yes. And then dilates vessels. Okay. Constrictions and dilations. If constriction occurs, what will be there? If constriction occurs, increases of force rate. Okay. Bronchi, where it is present? Lungs, basically. Okay. Dilates. Sympathetic nervous system dilates bronchi. Here, then it constricts. Parasympathetic nervous system constricts bronchi. Eye, or you can see in the eye. Dilates, especially this pupil in the eye, it constricts pupil. Okay, eye. Gastric secretions. Okay, gastric secretions. What about gastric secretion? Gastric secretions means what? See, you have in the stomach you have gastric glands. Produces HCl. Okay, the gastric gland produces HCl, which converts pepsinogen to pepsin. Okay, and you have in the intestine you have what? Succus entericus, the intestinal juice is synthesized. There are different cells. Okay, so gastric secretions are inhibited by sympathetic nervous system, stimulated by parasympathetic nervous system. Like that, see, similar salivary glands. In salivary gland. Okay, inhibits secretion. Can you understand? urinary liver reduces secretions of bile, increases bile secretion. Right? That's very, very important. Like how good of like constriction, dilation, contraction, relaxation, stimulation of secretion, inhibition of secretion. So like that, always in opposite manner, so balanced manner. So this is very essential for balance. Is it clear? So that's the importance of autonomous nervous system. Okay? So can I clean the board? Okay, fine. Now, so reflex action. So one side we saw voluntary actions by forebrain, and the other side we saw involuntary actions by autonomous nervous system. But now the other important response of feeling means the nervous system called reflex action. So what is reflex action? The actions which are faster than the thinking of brain towards the external stimulation. Okay, how can you define? The actions which occurs faster than the thinking of brain. And based on what? The external stimulations. If I throw something, okay, like all of a sudden you react. Don't even think what's going to happen. If anything is rushing, you just close your eyes over the wall. When you touch a hot pan over the immediately you respond. That action is called what? reflex action. Okay, what it is called? Hari, your Hari, reflex action. Okay, so process which occurs faster than the thinking is called reflex. How it occurs, that's very important. Okay, we have the sensory organ, for example, skin. Skin is a sensory organ. We have touch receptor for hot, for cold, okay, for heat, anything. There are different kind of receptors are present in the skin. Okay, skin is the organ which has what? A receptor. Any stimulation reaches your skin, that is received by what? The receptors which is present in the skin. And then this receptor receives the signal, and the signal is carried by what neuron? Of course, the neuron should carry the signal. They are not what? Sensory neuron or nerve fiber. They say neuron or nerve fiber. Okay, sensory nerve fiber, sensory neuron carries the signal. Where it goes actually? Where it goes? Yeah, spinal cord. It goes to the spinal cord. And then from the spinal cord itself, the impulses are integrated, and then what carries the impulse to the effector organ? Motor neuron. Here what neuron comes? Motor neuron. Motor neuron. And then here the effector organ basically. Effector. Okay, and then it results in what here? Last one. Can you understand? This is actually called what? Reflex arc. This pathway is called what? From skin. The receptor, the external stimulation is received by the receptor on the skin. Through sensory neuron, the impulse is transmitted to the spinal cord. From the spinal cord, the integration done, and the motor neuron communicates the information to the effector organ. Depends upon the stimulation you respond. Either you move, you jump, whatever. You cry, whatever. Can you understand? So this is called the reflex arc. This is called what? Reflex arc. Now, how it is possible in the sense, does the signal reaches the brain, or actually what is the role of brain here in reflex action? See, there are many from spinal cord to central nervous system. Actually, this is the reflex arc, but for extra understanding, every signal, every impulse reaches there. But there, what we have in between, we have a relay neurons, like the lightning. Have you seen lightning during the rainy days? Just like that, the lightning comes. So, like that, always there are signal transaction. What is, have you seen the relay? 100 meter relay, 400 meter relay, 1200 meter relay, people will be running, different people will be running. So, like that, relay neurons are present basically. They are on constant connection with the central nervous system and the spinal cord. So, the root becomes, since they are in communication, if these impulses communicate with the spinal cord, it is enough for the organ to respond. Can you understand? Since there are the presence of relay neurons makes the pathway shorter, they involve in the communication. So easily from the spinal cord itself they can get. They don't have to take the signal from here and come and pass on to the effector organ. Since the neurons, relay neurons are present, signal is communicated here itself with the help of the relay neuron in the spinal cord. That's the effect occurs. The response occurs. So this is called what? Reflex action. Okay? So the next thing is See, we have different techniques to diagnose the physiology, normal physiology, functions of organs and organ system. Okay, we have different there. If you are not well, if anybody is not well, if they go to hospital, what kind of experiment tests, diagnostic tests they do? Common diagnostic tests. Common diagnostic tests in hospital. Blood test. Then,
Pressure.
hmm?
Pressure.
Yeah, they look at your pulse. Physical observation. Whether you have fever or not. Show me your tongue. Show me your eyes. Give me your hands. They look at the fingers. Okay, temperature. And then they use stethoscope to check your heartbeat. Yes or no? Basically. And then, okay, you go for blood test. They ask your signs and symptoms. You have to meet fever, how many days? Vomiting, how many days? Like that, they ask physical observation and verification by different questions. They look for signs and symptoms basically, what are there in your body. And then they like prefer, okay, go for blood test, go for urine test, and then go for scanning. Okay, so depends upon the different kind of physiological, clinical complications. They give you a lot of prescription, means suggestions to do some kind of analysis. In that, some experiments basically are actually called what? Electrophysiology tests. What are they? Electrophysiology tests. What is physiology? Functions of study of functions of organs and organ system is called what? Physiology. Electrophysiology in the sense, see, in our body, some organs functions can be predicted using their electric potential. In our body, some organs functions, normal functions and abnormal functions can be predicted using the electric property. Okay, functions of organs means physiology of organs can be studied by electric properties, potentials of properties of the organs. You can say tissues, even cells. Okay, what is it? Electric potentials. Excitable property. Okay, we saw excitable property. What are the excitable cells present in the body? Where they are present? Where they are present? Excitable cells. Two examples of electric potentials. Electric means excitable cells in our body where the excitable cells are present. What are the properties of excitable cells? To generate, to transmit, to receive and respond. Yeah, impulse. There are two types of cells. What are they? Neurons and then cardiomyocytes. What are the two types of cells in our body? Have these electric potentials, neurons and cardiomyocytes. Where the neurons are present? Central all nervous system. Central nervous system, peripheral nervous system. Everywhere you have neurons. And then your heart. Cardiomyocytes makes your heart. Can you understand? So, with the electric properties of these cells, these organs, to study the functions of organ. Okay, you remember ECG. Okay, electrocardiogram. ECG. What do they do in ECG? They place electrodes in your body. Heart, when it contracts or whatever, it releases current, produces current. That current is recorded and based on the current electric impulses, it is converted into that electric impulses are collected by the electrodes and they are converted into digital signals. In monitor you see, listen, heart is having excitable property. Electrodes are placed. When the current is produced, that is absorbed by the electrodes. That the electrodes sends the current to a processor. The processor, what it will do, converts that electric currents into digital signals. And in the screen or in the paper, you can see the printing. Have you seen this ECG, the wave pattern? P, Q, R, S, T. Have you seen this? In one heartbeat, this is what? PQRST wave pattern. One heartbeat is alright. Functions of what? One heartbeat. One time if the heart contracts. These things happen. Atrial polarization, depolarization of atrium. Depolarization of ventricles. Means atrial contraction, ventricle contraction. So the current is produced during atrial ventricle contraction. That is measured. In 1 week, this is the wave pattern we can see. Okay? Heart rate, how we can measure? In 1 week, we can see such kind of wave pattern, PQRST wave pattern. How can we say that 72 beats per minute is there in our body? They record it in a long sheet. This one. In 1 minute, 72 such graphs comes, it is called what? Normal heartbeat. If your heartbeat is 40, what is it? It is called what? They call it as what? Bradycardia. Can you understand? If 70 beats per minute is not there, 72 beats per minute is not there, that you cannot see such pattern. And it is like this, for example, it will be like this. Can you see the distance? Just more. Only 40 can accommodate like that. So 40 beats only, 40 cycles only you are getting. That condition they call it as what? Bradycardia. Less heartbeat. Oh, heart is not functioning 72 beats per minute. Some problem. It is not functioning well. And then it is 120 beats per minute. This is called what? Tachycardia. Tachycardia. What is tachycardia? Your heartbeat is faster. Can you understand? For example, my auntie had this issue, tachycardia. Always her heart beats faster than normal. It was around 140 beats per minute. She went to hospital. They diagnosed in the heart Purkinje fiber is there. Bundle of his fiber and Purkinje his fiber. What is the function of that bundle of his fiber and Purkinje fiber? Sinoatrial node contracts. Okay, SA node contracts. Impulses reaches AV node, and then AV node transmit this impulse through bundle of his fiber and Purkinje fiber. The current is communicated to the ventricle and ventricle contracts. So the Purkinje fiber, bundle of his fiber or the nerve fiber, and in my auntie's heart, they found that the growth of neuron means it was too much wire. The Purkinje fiber was too much wire. That's why more signal transaction. That's why rate is more. Okay, and then they did some treatment, disconnected some nerve fibers, and she solved it. Can you understand? So, how they came to know that a heart is beating 7 more than normal beats? Electrocardiogram. That field is called what? Electrophysiology. Like that. If people have some neural defects, we cannot open and see, right, what defect is there. So they just place electrode and then they actually analyze the functions of nervous system. Is it clear? So that field is called what? Electrophysiology. Okay, ECG is one simple example of that. There are many tests, echo. Okay, electrophysiology, many kind of tests are there. Electrophysiology techniques. This is clear? So with this, let's stop. And what any doubt? Maybe actually thought of discussing plans that we will do in tomorrow's class, coordination in plans. Okay, so look into that, and anything which you cannot follow, you can ask me. So, quick summary, important things about which we discussed. We studied about mainly focused on autonomous nervous system. So, different involuntary actions like blood vessels, smooth muscles, glands, endocrine glands. So, that's our next topic of interest, endocrine glands, and uterus, alimentary canal. How do they regulate their function? Okay, by constriction, dilation, contraction, relaxation, stimulation, inhibition, property. Okay, sympathetic and parasympathetic nervous system controls, regulates the functions of the visual organ. And second part, we discussed about the reflex action, reflex part, the Stocker pathway. Okay, and then we discussed about what? Electrophysiological techniques. Okay, how based on the electric properties and potentials, the functions of the heart or any other organism diagnosed. So, if it is increased, what it is called technically? Increased heartbeat. Increased heartbeat. Tachycardia. Decreased heartbeat. Bradycardia. What is the big pattern I told you? PQRST wave pattern. Okay? Anyway, so next class we will be continuing with mostly plants. Okay, and then we can again go for glands in. Maybe we can finish glands and also can go for plants. Okay, glands, endocrine glands in human beings. And then we can go for plants, that's easy. Orange plants. Anyway, take care. Thank you so much. Yeah, thank you.